Alrighty, so we're back once again in our little corner of the world. So we're looking at question 11 here. So this is Mr. Bunk deposits $15,000 with a flat bank, which pays him a flat simple rate interest of 7.2% on his original deposit per year. Mr. Bunk adds no further deposits to the account himself. How long will it take before Mr. Bunk's funds grow to $35,000? So there's a few ways we could do this. Obviously, we could just do this solving it. And if we solved it, it wouldn't take too long at all. I'll show you that nice and quickly now. So T naught in this question is $15,000, and our D value is going to be a positive, and it's a percentage one, so it's 7.2 on 100 times the starting condition, which is $15,000, and in this case, that's equal to $1,080. Alrighty, so there's our D, there's our T naught, and once again, we can do this in two different ways. So we're interested, oh sorry, I didn't specify my variables. I keep doing this, so let's specify my variables. So Tn is going to be the value of his account after n years, because he gets that after per year, so after n years. Alrighty, and we're interested in when the value of the account, so we're interested in when Tn, the value, is equal to $35,000. Okay, so we can solve that nice and quickly. Apologies, it won't look too pretty on this, but just using the Tn rule. So Tn is equal to T naught plus Nd. Substitute everything we know in. We got 35,000 on the left-hand side is equal to T naught, which is 15,000, plus N, which we don't know, times D, which is 1,080. Take 15,000 from both sides, we get 35,000 minus 15,000 equals, and then N times 1,080. That leaves us on the left-hand side with $20,000 is equal to N times 1080. Now we're going to divide both sides by 1,080. So 20,000 over 1080 equals N. And that's equal to, that's the D button, 18.5. Now remember, we rarely ever want to know things in decimals, especially when dealing with arithmetic sequences, okay? So since you get interest yearly, that means that he's going to have to wait until the 19th year. So we're gonna have to round up here. Therefore, it will take 19 years for Mr. Bunk's funds to grow to 35,000. Okay, I wanna show you an alternative way of doing this, which is equally valid, but just a slightly different workflow. So let me set that up. Alrighty, so you can see here I've just set up my equation. I'm just gonna substitute in D, which I worked out over before, so 1,080, still have to work that out. And now all I'm gonna do is use my calculator to finish the rest of it. So 1,500, and then equals, set it into the calculator's memory, and then we're gonna go answer plus 1080, and then we count 1 year, 2 years, 3 years, 4 years, 5 years, 6 years, still not over 35,000. 7 years, 8 years, 9 years, 10 years, 11 years, 12, 13, 14, 15, 16, 17 years, still not over. 18 years, still not over. 19 years it takes to work it out. If you were to do something like this though, you'd need to show some working out. And the working out you'd show is you'd show T naught, well we already know what T naught's equal to T naught is equal to 1,500. Then you'd say that T1 is equal to, well, let's go back to the beginning. And I'm actually just going to record this now so I don't need it. So dot, dot, dot. And then get rid of that. T19 is equal to 35,520. So you kind of do a mini tabulation and mini tabulate table basically, just with each of the different terms you work out, but you do like a 1, 2, skip a few. So 1, 2, skip a few, 99. And you can show that that's the best one. And so we'd clear the screen, oh, not clear the screen, so 1500. And then answer plus 1080. And then we can just go, that's 1. Oh, that was the one we wanted. It was 16,080. Okay. And usually you'd also show the one just before to show that it is the first one to work. So I would often put 99 and 100. If you're going 1, 2, skip a few, 99, 100, you should put 99 and 100. So in this case, you do the one before and the one we actually want. So that was 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. I think that's 18. We'll know when I click equals the next time. So 33,360. Or is that 17? Did I miscount? I miscounted. So the only difficulty with this method is you do have to count correctly, because if you count incorrectly, you stuff up these numbers. Alrighty, so I just thought I'd show you, if you prefer the algebraic method, that's perfectly fine, but here's 2 methods, just in case you wanted it. Alrighty, see you in the next one. Goodbye.